Okay, the next section we're going to do is the surface area of pyramids and cones. In order to show where the surface area of a pyramid comes from, you can take a pyramid and unwrap it. And it looks like that this pyramid has a square base. We're going to ignore that for a second, and then we're going to take all of the triangles. So if you unwrap all the 4 triangles and you line them up, you'll notice that we could draw a nice rectangle around them. And if you compare how much area is in between the shaded portion and the non-shaded portion, you'll see that they're the same, which means that the area of this rectangle is going to be, well, the area of all the triangles is going to be half of the rectangle. And how do we figure out the area of the rectangle? Well, the area would be base times height. And the base is each of these 4 added together, otherwise known as the perimeter of the base. So this is the perimeter. And then the height of all of these is the slant height of this triangle. And we'll call this fancy L. We use a little cursive L because otherwise an L looks like a 1 or an I. Which means that the area of a pyramid is going to be the area of the base plus 1/2 of the perimeter times your length. So why don't you go ahead and write that down there. The area of everything is 1/2 of the perimeter times the length plus the base area. Now the base area can be found all different kinds of ways. That's why they just use a capital B instead of having one specific formula there. So here's our first example. We have a pyramid with a square base. This is a regular pyramid. So let's go ahead and try and figure out what the surface area is. We know the surface area is 1/2 perimeter times length plus the area of the base. The perimeter is 5 times 5, or 5 plus 5 plus 5 plus 5, so 4 5s. The slant height is 9. And then the area of the base is 5 squared, or 5 times 5. 4 cut in half is going to be 2. 2 times 5 is 10. 10 times 5 is 90. Plus 25 looks like 115 inches squared. Let's go ahead and try our next one. This one, they don't tell us our slant height, so we need to figure that out ourselves. Luckily, we know something about special right triangles. Since this is 10, half of it would be 5. And there's a special right triangle with a 5, 12, and 13. So since now we know that our L is 13, we could say our surface area is 1/2 of our perimeter being 4 times 10 times the length, slant height, 13, and then the area of the base, which is 10 squared. So 4 cut in half is 2, 2 times, let's do 10 times 13 is 130, 130 times 2 is 260. Plus 10 squared is 100, giving us 360 meters squared. I want you to go ahead and pause the video and try these yourself. This one is not going to be a nice number here. This one's going to be a 3 and an 8. And this one here, you're going to have to figure out the area of the base of the triangle given that one part is 4. All right, so go ahead and pause the video, and then we'll come back in a second. All right, so we'll go over number 3 first. We could say that the area of or in order to find L first, you have to do 3 squared plus 8 squared equals L squared. That's why I set that up there. I solved for L, but I didn't necessarily just write down what L equals to. I didn't write down the rounded answer because I wanted to round at the very end. So I said that the area of the base, so that's B squared, there's our 6 squared, plus 1/2, the perimeter is 6 times 4, because there's 6 of them, times the square root of 73. And I put that in my calculator, I got 138.52, but it rounded to the nearest tenth. So now in order to find the area of a regular pyramid, it may not look like it, but it's regular, which means that it's an equilateral triangle. So an equilateral triangle has all sides being 4. So I drew an equilateral triangle here. All sides are 4, so that must mean that this is 2. And if I split this in half, we end up getting a 30, 60, 90 triangle, which means that the height of our triangle is going to be 2 root 3. So the area of the base is 1/2 base times height, and 1/2, one of the bases is 4, the height is 2 root 3, and then 1/2, the perimeter is 4 times 3, that makes 12, times the slant height, which is 6. And then so we ended up getting 4 root 3 plus 36, and I just put that in our calculator. Okay, so the next section we're going to do is the surface area of a cone. Now if we're in class, I would go through the origin of where this comes from, but I'm just going to go ahead and show a brief description of what's going on. You could take a cone and you can unwrap it. And if you unwrap the top part of the cone, you'll see that it looks kind of like a Pac-Man shape, and then this is the base of the cone, which is a circle. So we're adding these both together. And the area of this part is pi r squared. The area of this one ends up being pi r L. This is L right here, so pi r L. So the area of them both, the surface area, is going to be pi r squared plus pi r L. Pi r squared plus pi r L. So let's go ahead and use that in an example. They don't tell us what L is, so pi r squared plus pi r L. We do know that r is 6, so we need to figure out what L is. We could say this is 4, this is 3, this is a 3, 4, 5 triangle, which means that this one must be 10. So we could say this is pi r is 6 squared plus pi r is 6, and L is 10. So 36 pi plus 60 pi, which is 96 pi centimeters squared. I don't know if they want us to round to the nearest tenth. It does say round to the nearest tenth, but you guys can do that yourself. Just take 96 and multiply it by 3.14, or multiply it by pi, and you can round. All right, this is another Pythagorean triple. You can check yourself, but I'm pretty sure that r is 7. So we have pi r squared plus pi r L. We have pi, r is 7 squared, pi 7 times 25. Oh, that's nice. 49 pi plus 7 times 25. Okay. $175 plus 49. 224 centimeters squared. And then you can go ahead and multiply that yourself to figure out round to the nearest tenth. All right. I'll give you another opportunity. Why don't you go ahead and pause the video and try to find the surface area of these shapes as well. Okay, here is my work for the surface area of these two shapes. Since my diameter is 6, I said my radius is 3. This is another 3, 4, 5 triangle. Our lateral height is 5. So pi r squared plus pi r L, pi 3 squared, pi 3 times 5. Our next one here, we just needed to figure out what our base was. Once again, I did a 3, 4, 5 triangle, except I said 2.5 multiplied by 2 is 5, 2 multiplied by 2 is 4, so that means this is 3. Well, 3 cut in half is 1.5, so then our radius is going to be 1.5. All right, and the last thing we're going to do is the surface area of composite figures. So when we're trying to figure out the surface area of composite figures, we want to write down all of the surfaces that are being shown. So let's write down all of the surfaces that we're going to use. We have the lateral cone part. So the lateral face of the cone. We have the lateral sides of a cylinder. So that's all the way around here. And then we also have the base. Now we need to just write down what each of the formulas are for each of these pieces. The lateral face of the cone is pi RL. The lateral sides of the cylinder, that's the circumference times the height, so 2 pi r times height. And then the area of the base is pi r squared. And then we could just fill in all the pieces here. It says that our radius is 28, so 28. Our lateral height, we don't know that yet. We need to figure out what that's going to be. So let's go ahead and do a little bit of math. We know that this is 45 and the total is 90, so we know that this is 45 as well. Let's see if we could break each of these down. If we could divide them by the same number. 45 squared plus 28 squared, take the square root. Okay. This is probably going to be a whole number. $53, okay. And then we have 2 pi, our radius is 28, our height is 45, and then pi, our radius is 28 squared. Now, I could spend time to evaluate this, but I'm running low on time, so I'm going to go ahead and move on to the next problem. We just add these all together, put them in terms of pi around it. Okay, so our next one here is a cube with a pyramid taken out of it. So we have a total of 5 faces of our cube. So our surface area is 5 faces. I would say it'd be 6 faces, but this part is being taken out. So 5 faces of cube. Plus, we have all of the lateral faces of the pyramid. So what is the 5 faces of the cube? What is the area of one of the faces? The area of one of the faces is 2 times 2. So 5 times 2 squared, because 2 squared is the area of the face. So plus the lateral faces of the pyramid, and that's going to be 1/2 of the perimeter times the length. So we need to also figure out what the length is going to be then. Okay. That's an easy way to show that. I guess we could just draw a diagonal then, since it's going toward the center of our, since it's going to the center of our, so if we were to look at it from the side, it would look like this, right? So this is 1 and this is 2. So we want to figure out what L is going to be. So 1 squared plus 2 squared equals L squared. So this is going to be a total of 5. So we have the square root of 5. That's going to be L. So perimeter, the perimeter is 2 times 4 and times the square root of 5. So we have a total of 20 plus 4 root 5. We'll say that's yards squared. I'm just going fast through this because we're short on time. So go ahead and try these 2 problems. Pause the video right now. Okay, and here are the answers to that. If you have any questions about these problems, please come to the Q&A later on today or tomorrow. All right, and here's your assignment.